Example 2. The cord shown in the figure supports a force of 500 Newton and wraps over the frictionless pulley. Determine the tension in the cord at C, okay, and the horizontal and vertical components of the reaction at pin A. Okay, so we will first write our free body diagram. So let me zoom in. Okay, and it is very helpful whenever we do equilibrium problems to draw our free body diagram. Okay, so if we have our circle here, we have 500 Newton going down, right? That is 500 Newton going down. And our tension of our rope is subjected to 30 degrees. This is our tension, and this is our 30 degrees. 30 degrees, right? Okay. Now, this is our pin A. So, of course, it says pin here. So, therefore, it resists both vertical. Let us call that, let me use color red. Okay. We have A sub Y going up, right? Because by inspection, the y component of T is going down, 500 Newton is also going down. Next would be its x component. Now take note our uh, T is the only force there that has a horizontal component and it acts to the right. So therefore our x is to the left. 2 constitutes equilibrium, right? So and our radius is 0.5 meters. 0.5, 0.15. Okay. Now, if we do summation, again we have our three equation of equilibrium equation. Forces x is 0, forces y is 0, and summation at a certain point is 0. Now, if we do a summation of forces x, and we have two unknowns, a sub x and the x component of our tension. So let us move on. F sub y. We have a sub y. We have given 500 Newton, but we also have t sub y, right? Going down. So the next best thing is we do moment summation, where, of course, at our point A. Summation of moment about A is equal to 0, assuming, of course, counterclockwise is positive. Now that means our 500 Newton is counterclockwise while our tension is clockwise. So that it means this is 500 times its perpendicular distance, which is the radius of our pulley, which is 0.15. 0.15. Now, don't get confused that although our tension is provided 30 degrees with the horizontal, now take note on where we are taking the moment, and that is at the center of our circle, of our pulley. And no matter where we apply our uh, force in our uh, over our circle, and if it is tangential, let's say you wrap your rope around your circle, it is always tangent to your circle. So it means that we don't have to use the angle of inclination provided here, which is 30 degrees. We just have to multiply our tension immediately with the perpendicular distance from A, and that is its radius. So it means that is 1 minus t times 0.5 is equal to 0. So it means T times, okay, T, T times 0.5, 0.1515 is equal to 500 times 0.15. So it means our tension is equal to 500 Newton, which is indeed reasonable kay if birahon ang nimo ang imuhang rope even over a certain pulley, over a certain structure, if mao na ang amount of force sa imong pagbira sa imong rope, mao na guna siya tanan ang mga amount of force nga na-experience of your rope whenever over the entire length of your rope. So it is just justifiable nga kung 500 newton ang imong gibira at one side, 500 newton pod nga force na experience sa imong rope. That is that means T is equal to 500 newton. So now we are tasked to find for the horizontal and vertical components. So that means we do summation of forces X is equal to 0, assuming upward positive, and that is A sub X minus 500 minus T, T cosine 500, T cosine 30 is equal to 0. So therefore, A sub X is equal to 500 plus 500 cosine 30 degrees, and A sub X is equal to 500 cosine 30 is 433 plus 500, that is 933.0127019 Newton. And for our X, sorry, I'll just change it. This is Y. Let's just change it to Y, sorry. This is Y, Y. And the same, cosine 30 is Y because we are measuring our 30 degrees from the vertical. It means that our Y will be cosine and our X will be sine. Oh yeah, change this one. Okay. This is A sub Y, A sub Y. Now, summation of forces, X is equal to 0 to the right positive. That is A sub X. That is T sine 30 degrees. This is T sine 30 degrees minus A sub X is equal to 0. Because we are assuming that A sub X is to the left. So therefore, A sub X is equal to 500 sine 30 degrees. So A sub X is equal to 500 sine 30 is 250 newtons. Okay.